Hi, everybody. I hope everybody is okay. Okay, today I'm going to talk about a new tool that we are implementing here in our lab. This tool, its name is Mattson Cooker. This tool is a kind of tool to cook roots, but this is new improved design from a tool used to cook beans. Let me present you the tool. This is the tool that we we built. These tools is composed for 9 needles to penetrate each root, because this tool is measuring the time necessary to get soft every piece of fruit. So let me show you some results. In this moment, I'm gonna present you the result corresponding to the harvest of 9 months that we had last year of our RTB genotypes. In this moment, you are watching the difference between two methods that we are using here at the lab. First method is the traditional method that people use to measure the optimal cooking time. This method is known by forking. This method consists in touch every part of roots with a fork and determine if the fruit is already boiled or not. This method is a little suggestive because depends especially on the operator, on the strength of the operator. While the other method known by Mattson, this is the Mattson method, like I said before, this method measure every time to get soft in each root. So in this moment, we can see, for example, in the x-axis, the root session, because we previously to put all roots into the pot, here at the lab, we made a sampling. So this sampling consists in, let me show you the sampling because I'm not here. A moment. This is the sampling that we made here at the lab. The sampling consists in take 11 roots, and we took 10 roots, and per each root we took 1 cylinder. The sampling consists in take 1 piece of root of each cylinder taken by each root, and 1 piece of root is going to the fork method cooking, and the other piece of root corresponding to the same cylinder going to the Mattson cooking method. So this is the graphical chart that we made last year. So as you can see here, for example, in root number 1, we have the piece of root 5 and piece of root 6. And this is the representation. Piece of root 5 in this case is representing both pieces roots. In this case, the pink line corresponds to the fork cooking method, and the blue one corresponds to the Mattson cooking method. So as you can see, in this case, this harvest corresponds to the harvest of 10 months. And for example, you can see that in the most of the genotypes, both methods are highly corresponding, except in one genotype. For example, here in col 1516, we have in the fork method, for example, in this piece of truth 55, this piece of truth was very hard to the operator that was touching that piece of truth with fork, while the the same piece of truth for the Mattson was very soft. And in this case, this is are the same results, but for 11 months of like last year. So, for example, the correlation. So, in this case, this result corresponds to a harvest of 11 months. And like I said before, this correlation was much better than 10 months because in this moment, the operator was the same person that cooked the roots by fork method, was the same person that cooked the force by Mattson method. So in this case, for example, call 1505 was had very spectacular correlation per each piece of root. At the same thing happened with call 1516. For example, CM 6372 was much better than before. So, according to the results presently, before we decide to make a correlation between two methods and try to fit a linear model to see the example,
yes.
the adjust coefficient was 0.55 Cs. This is a good adjust coefficient, and the correlation shows a high correlation between two methods, and this gonna us to think you that we can replace the traditional method with this new method by Mattson cooker. So in this case, we are going to present the correlation between cooking times and water absorption, because as you know, here at the lab, we have an excellent correlation between two variables. Like you see, the correlation between cooking time in this case is with data by fork, and we had a good correlation. And in this other case, we have the similar good correlation between cooking time by Mattson machine and water absorption all data. Okay, so this is other result that that are assured that we can replace the cooking method by fork traditional method with the cooking method by Mattson cooker. Thank you so much.
Thank you, Luis Fernando, for your presentation, and congratulations to the CIAT team for this proof of concept on the correlation between the traditional fork method assessment and this new adapted tool, which is the Mattson cooker. Maybe can you please show again the Mattson cooker, because there were participants who were joining a bit late. Okay, good. Thank you. So we have now time for questions. So we open the floor to questions, comments from the audience. Let me see if in the chat there's any question. Okay, not for now. Is there any need for clarification or a technical question for Luis Fernando or CIAT colleagues who are using this tool?
Or any comments by Thierry, maybe?
There's a question from Dominique asking how many repetitions and the number of roots per, I assume per variety or per genotype. How you
there are questions from
assess?
Dominique.
Yes.
How many repetitions and how many roots for one to analyze one genotype? I think with Fernando, you can show again the diagram of the sampling diagram where we cut the roots. Yeah, this one. Do you want to comment?
Yep. Okay, thank you, Thierry. Okay, for the sample, we took 8 roots. Per each root we take 1 cylinder. So, like I said before, this cylinder is split in 2 pieces of roots. Like are you seeing this? For example, in this case with root number 10, we split this piece of roots. This cylinder corresponds to the central section in 2 pieces of roots. 1 piece of root is going to cooking by fork method, and the other piece of root is going to Mattson cooking method. So in overall, we have nine replication per each method.
Dominique, is it clear for you now?
Yes, just a comment. Did you observe a difference between proximal, central, and distal?
Yeah.
Because you are evaluating on the different parts, but I can see the difference in the graph.
Yeah, yeah, and this difference corresponds to the to each part of sorry. This difference corresponds to every section root of each root. For example, let me show you again the sample chart. Let me pick, for example, here we have the cylinder. This cylinder corresponds to the distal section, and this section, the distal section and proximal section, are known by being hard section. So let me show you this section specifically in the graph. The number of 55 and 56. This section, for example, are this section correspond to 2 pieces of roots, and as you can see in this case, we can see that these pieces of roots are harder than previous piece of roots.
Yes, but it's not the case for all the roots, for all the genotype.
No, it's not the case for all the roots, because
and people are eating the free part of the roots, distal, proximal, and central. Is there any big difference by genotype on hardness in the different part of the roots?
Yeah.
When you eat the cassava, you eat everything.
Yeah, but actually, as you know, cassava has very high difference among each piece of part into the same root. That's not only happen with hardness, that's happened, for example, with beta carotenes and also dry matter and also cyanocytes. It's very irregular into each root. So
to comment on this, I think the variability between different roots can be higher than the variability between proximal, central, and distal of one root. So the differences between proximal, central, distal, in the end, don't matter that much because we have more variability between different roots of the same genotype.
Yes, I think so.
Okay, thank you. Very clear.
thank you.
There's a question in the chat box from Ephraim. Did you observe any variations with variable diameter of the roots?
No, actually, I didn't measure the diameter of the roots.
Okay.
So,
Well, again, we use standard size.
go ahead, Owen.
We use standard size of the roots, so the diameter is always about between 5 and 5.5 centimeters.
Between 5 and how many?
5.5 centimeters.
Okay. Good. Question of clarification from Suzanne. So she's not familiar with the Mattson cooker, like I think most of us. Could you please explain again how it works and how cooking time is derived? So how do you actually extract cooking time? How does it work in practically?
This is the Mattson cooker, and this machine is connecting by this cable to a little computer known as Raspberry Pi. Raspberry Pi is a little computer like, for example, Arduino, and this computer is controlling every time to spend each piece of fruit to get soft. So how can I take this different time? Each piece of fruit, in this case, when each piece of fruit is more than 5, 6, or 10 minutes into the boiled water, this piece of fruit start to getting soft. So when the needle pass through all root, the needle touch, for example, let me show you with a little zoom. Show you this button, as you can see. This button is measure the time the time necessary to get in soft each piece of fruit into a pot with boiling water. I can send you more supplemental files with some videos and more picture to get more clear with the working of Mattson cooker.
Thank you.
As I understand, you are boiling the roots and you are creating the time for the probe to go inside the roots, and it depending on the easiness to cook, and really the force to go inside the roots is the time to go to all the probe to go inside the root is measured.
Can you repeat please again, George?
I just explain how it's working. It's the time to the probe to go inside the roots during the boiling, because it's you are boiling the roots, and we are evaluating the time of the probe to go inside the roots, and it's evaluated by the sensor that you have on the top of the Mattson cooker.
Yeah.
Normally it's used for beans. You put 9 beans and you have the time for the probe to enter the beans when they are cooking, but they adapt for cassava, and it seemed working very well in comparison with the fork prop that we used before.
Yeah, but with beans is with more than 9 beans.
Mhm.
With cassava, in this case, we just have 9 pieces of fruit cassava, while with Mattson cooker for beans, I think was with 19 or 20 seeds by genotype. Moment, I think it's a very high possibility. But I think the example, the weight used to measure each piece of fruit in this case was 90 grams. So I think with sweet plantain or banana, it's necessary to reduce this weight, because the plantain and bananas are softness than roots.
Okay, Thierry, you want to add some more details to the answer? No? So Toyin, if you have a question, please.
Okay, thank you once again, Luis. This is quite informative. I just want to ask, has any correlation been found between sensory hardness by using the fork method and the hardness of the cassava using this Mattson cooker during cooking? Because it's like the idea is to replace the fork method with this more precise method.
I think you asking me about
yes.
this.
Okay, good. I can see the answer. Yeah.
Yeah, actually, we have in this moment this data correspond to data of last year. There are few. There are few than we have today. So in this moment, we had a good correlation among two methods. So we hope that with the new data collecting this year, this correlation is going to very more high.
Okay, thank you.
Welcome.
So Dominique is asking whether you are considering to publish this new method in the upcoming special issue dedicated to RTB, quality traits and methods for measurement of the Journal of the Science of Food and Agriculture. So this is a special issue we are actually coordinating at RTB Foods level. So any plans to publish this method in the special issue? Have you discussed that with Thierry maybe?
Yeah.
After the meeting.
It depends on the time. We are very short on time available to write.
But I think it's a good opportunity to share these results and other results, because we can share you more results in other way, in other methods, mathematical method to predict optimal cooking time, but we can maybe schedule another session to see what happened with this new mathematical method to predict optimal cooking time. Yeah, Dominique, 2 years of harvest, because that is the time that we have the machine since 2021 until today.
So I think we can close today's webinar. Thank you very much, Luis Fernando, for this presentation, and above all for accepting to present in a very short notice. Thank you very much.